Alright, so today we're going to cover the Pythagorean theorem and special triangles. Our objectives are we're going to find reference angles on the unit circle, and we're going to use reference angles to identify trig ratios. Alright, so first thing we're going to do is we're going to solve for the missing side for our triangle here. And we have a right triangle with legs of 3 and 5 and a hypotenuse that's unknown to us, c. So we can go ahead and substitute in our values here. One of our legs will be A. And so we can set one of the legs to equal A. We'll set 3 equal to A here. And we'll set B equal to 5. And this is quite easy. We're just going to square 3 and add that to 5 squared. And that'll give us C squared. So it's 9 plus 25 is equal to C squared. 9 and 25 is 36. Equals C squared. In order to solve for C, we just take the square root of both sides, and we get C is equal to 6 here. Technically, we should get C is equal to plus or minus 6, but when we're thinking about a length of measurement or unit of measurement, we're not going to have negative values. So C is equal to 6. That is our hypotenuse for this right triangle. In our next example, we're going to see that again we have a right triangle. This time we know our hypotenuse, which is a length of 24, so that's going to be our C value. We know one of our legs is equal to 12, so we can set A equal to 12. And we're going to solve for B, which means we're going to have to isolate B squared. So in order to do that, we can take A squared and subtract it from both sides. And that'll give us B squared is equal to C squared minus A squared. To solve for B, we take the square root of both sides, and we get B is equal to the square root of C squared minus A squared. At this point, we can substitute our values in for C and A. So B is equal to the square root of 24 squared minus 12 squared. When we put that into our calculator, we're going to get a result of 20.78. Now in our next example, we're going to draw this, we're going to be given an ordered pair of negative 5, 2. From that, we're going to draw a triangle on the coordinate plane, and we're going to try to find the missing side. So I'm going to sketch a coordinate plane here with an x-axis and a y-axis. Our coordinates are negative 5 and positive 2. I'm going to draw a right triangle based on this point of negative 5, 2. And much like we take reference angles, I'm going to draw it so that my right triangle or my right angle ends up on the x-axis. My point will go towards the origin, and so my hypotenuse will go from the origin to negative 5, 2. Again, my right angle will go on the x-axis, and from here I can determine the sides of my triangle and figure my hypotenuse. If I think about it this way, I know that one of my legs is the length of negative 5, the other leg is the length of 2. Now, reality would state that if we're talking about finding the length of the hypotenuse here, we wouldn't use negative values for length. It's kind of irrelevant at this point because we're going to square both of our legs anyways, which means if I square a negative number, it becomes a positive. So, knowing our Pythagorean theorem says a squared plus b squared is equal to c squared, I'm going to go ahead here, and I'm going to plug in 2 for a and square it, plus 5 squared, or negative 5 squared, and that's going to be equal to c squared. When I do that, I get 4 plus 25 is equal to c squared. So 29 is equal to c squared. I take the square root of both sides to solve for c, and I find c is equal to the square root of 29. 29 is a prime number, so I can't reduce that radical any further. If I did want to write it as a decimal, I could do that. I'm just going to go ahead and take the square root of 29 in my calculator, and it's approximately 5.39. We can go ahead and do the same with this next example. Given the ordered pair -4, -7, both our x and y values are negative, so I'm going to have a right triangle that I'm going to draw in the third quadrant. My x value is -4. My y value is -7. Again, I'm going to draw my right angle on the x-axis for my right triangle, and my hypotenuse is going to go from the origin to the point -4 and -7. In this case, my legs are going to be -4 and -7, and again, I'm going to try to find the hypotenuse. To do that, I'm going to take one of those points, -4, and square it, add it to -7 squared, and that's going to be equal to c squared. When I do that, I get 16 plus 49 is equal to c squared. That means c squared is equal to 61. I square both sides, or take the square root of both sides, and c is equal to the square root of 61, which is approximately, put that in my calculator, 7.81. As a result of some things we learned in geometry, you might remember your special right triangles. For a 30, 60, 90 triangle, right triangle, the hypotenuse has a length of 2, the side opposite of 60 degrees is radical 3, and the side opposite of 30 degrees has a length of 1. For a 45, 45, 90 triangle, the hypotenuse, that's the longest leg, or longest side I should say, has a length of radical 2, and both legs are equal in length of 1. And that makes sense. 45-degree angles should produce the same length on the opposite side of the triangle. Given what we know about a 30, 60, 90 triangle, we can then solve for missing sides and hypotenuse of any type of 30, 60, 90 triangle by creating proportions. So I'm first going to draw in our 30, 60, 90 reference triangle. I know that the hypotenuse is opposite the 90-degree angle. The side opposite the 30-degree angle is going to be a length of 1. If the side opposite 30 is a length of 1, my hypotenuse is 2, and the side opposite the 60 degree is 3. Radical 3, I should say. So now what I'm going to do is compare lengths of triangles. So I'm going to set up proportions. And the first one I'm going to set up as a proportion of the side opposite 30 degrees. And for my side opposite 30 degrees, I have on one triangle a length of 14. On the reference triangle, I have a length of 1. I'm going to set that equal to my side opposite 60. And we're going to go ahead and solve for x. The side opposite 60 in the same triangle with the side opposite 30 is 14 is going to be our unknown x. If I go to our reference triangle, the side opposite 60 is radical 3. So I have 14 over 1 is equal to x over radical 3. I can then go ahead and cross multiply. I'm going to take 14 times 3, which will give me 14 radical 3. I'm going to cross multiply the 1 and the x, and I'm going to find 14 radical 3 is equal to x. So therefore, my side opposite 60 degrees is 14 radical 3. Now there's a couple ways I could solve for y. I could use a Pythagorean theorem here at this point to solve for my hypotenuse, or I could set up 2 more proportions. I'm going to set up 2 more proportions. And we're going to compare the side opposite 30s again. That's what SO30 means. And I know I have 14 over 1. That's the triangle that I'm looking for the y value in versus the reference triangles, side opposite 30. So now I'm going to look at the hypotenuse. For my right triangle, in which the side opposite 30-degree angle is 14, my hypotenuse is y. For my reference triangle here, I see the side opposite, there is side opposite 90-degree angle. The hypotenuse has a length of 2. Again, I'm going to cross multiply 14 times 8, or 14 times 2, I should say. My apologies. And that's going to be equal to y times 1, or y. Well, 14 times 2 is 28. So my hypotenuse here is equal to 28. If I've done this correctly, I should be able to take 14 times radical 3, square that quantity, add it to 14 squared, and that should be equal to 28 squared. And you can check that on your calculator. Now I can do the same thing for yet this other 30, 60, 90 triangle. Again, I'm going to start by drawing in my reference triangle. Hypotenuse of a length of 2. The side opposite 30 degrees is a length of 1, and the side opposite 60 would be radical 3. In this case, I know I have my hypotenuse on both triangles, so I'm going to set up my ratios based on what I know in both triangles, which is a hypotenuse. So we're going to go with the known, or the triangle with the unknowns, over the triangle with all knowns, so 1 over 2. The 1 represents a hypotenuse in my triangle with unknowns. My 2 represents a hypotenuse from my reference triangle. I can then set it to equal to the side opposite 30 or the side opposite 60 ratios. We're going to start with the side opposite of 30, and we're going to solve for y. Since we put our reference, or our triangle with unknowns on the top or in the numerator, y will go in the numerator. That's the side opposite 30 in this triangle. When my hypotenuse is 2, the side opposite of 30 is 1. So I will have 1/2 is equal to y over 1. Of course, y over 1 is just equal to y, so I have y is equal to 1/2. Now something you might have noticed here is that the side opposite 30 is always half of the hypotenuse. So maybe you could have figured out the y value already. And from here, again, solving for x, I could easily set up proportions, or I could use the Pythagorean theorem. Given that I'm going to work with fractions here, let's just go ahead and set up proportions. So again, we know both the hypotenuses in both triangles, so I'm going to start off as one of that, use that as a proportion, or ratio, I should say. We're going to take a ratio of the hypotenuses in both triangles. So again, we're going to start off with 1 over 2. That's the ratio of the hypotenuse in one triangle compared to the other. And I'm now going to set up a proportion based on my side opposite 60 lengths. Well, the side opposite 60 in the triangle with the unknowns is x. The side opposite 60 in the reference triangle is radical 3. And this is going to require me to cross multiply, which means I'll have 2 times x, or 2x, is equal to 1 times radical 3, or radical 3. To solve for x, I'm going to divide by 2 on both sides, and I get that x, or the side opposite 60, is equal to radical 3 over 2. And there I have both my unknowns in my triangle, my 30, 60, 90 triangle. Finally, to close today's lesson, I'm going to look at the 45, 45, 90 triangle. Now, one thing I remember about a 45, 45, 90 triangle, as I'm drawing my reference triangle, is if the hypotenuse is radical 2, both legs of that 45, 45, 90 triangle are going to be the same length. After all, the fact that they're opening the same way, i.e. they have the same angle, would produce the same leg length. So really, I can say in this problem that x is equal to y because they're both opposite 45-degree angles. So I really only have to solve for one leg here, and I get both legs. Now, looking at the triangle with the unknowns and the triangle with my hypotenuse, both of them or the triangle, sorry, the reference triangle. Both of them are known hypotenuses. So I'm going to set up a ratio of the hypotenuses. I'm going to go 1 over radical 2. 1 over radical 2 will give me the length of hypotenuse in the triangle with the unknowns over the length of hypotenuse in my reference triangle. I can pick which either side I want. It doesn't matter. The side opposite 45, whether it's x or y, is going to be the same in both triangles. So, looking at the side opposite of 45 in our triangle with unknowns, I can call it x. Doesn't matter. I could have also called it y. And the side opposite 45, both side opposites 45 in my reference triangle is 1. So I could say that x is equal to 1 over radical 2. Now, we don't like to typically leave radicals in our denominator, so we have to rationalize our process. In order to do that, I want to get radical 2 out of the denominator. If I multiply radical 2 by radical 2, I end up with the square root of 4, which is just going to be equal to 2. Now, in order for me to multiply by radical 2 in the denominator, I need to multiply by 1 over radical 2 by something that, while it might change its appearance, doesn't change its value. That's the number 1. The only way I can make this 1 is by putting a radical 2 on the top. I'm going to have 1 times radical 2, which is going to be radical 2. And, of course, that won't change, so I'll have 2 radical 2 is equal to one of my leg lengths, and actually both of my leg lengths in this 45, 45, 90 triangle, in which I have a hypotenuse of 1. Okay. All right, that's today's lesson. It's a very short lesson. Please go ahead and do your 10.2 homework. There'll be some questions on finding your x and y values. You'll have to, again, set up proportions and ratios to compare the reference triangles that we go ahead and give back earlier in the assignment to triangles with unknowns in it. You'll have to work with the Pythagorean theorem. And as the late, well, he's still alive, the former NBA great Shaquille O'Neal used to say, unlike the Pythagorean theorem, I can't be solved. Unfortunately for Shaquille O'Neal, he forgot that the solution to the Pythagorean theorem is c squared. All right, good luck with your homework.